Another type of functions in Matlab are so-called function functions. Now this may be confusing, but the whole idea is that that given function, let's say function A, works on another function. So in other words, the other function, for instance B, is just one of the input arguments into our function A. And that means that just as we give in input arguments, there is a place where one of them will actually be a name of the other function on which we are trying to perform some operation. And let's go right away to an example. So first, a small high school recap. When we have a parabola, which is given by a quadratic equation like this, the shape is roughly like that. And sometimes we may be interested in finding the minimum of that function. So where is that lowest point? Where is the smallest value of the whole function? So now this is a function. It's a curve, it's a line, call it whatever you like, but actually it is a function. We define that parabola using this formula. On the other hand, minimum search, so looking for a minimum, is an algorithm on its own, and it can also be written in a function. And Matlab already has such a function for looking for a minimum. It's called fmin search. And so that fmin search works so that for a given function or a given set of values, it will perform search starting from somewhere. So how it does is actually that if we have this x-axis, you have to tell it from where it should start, so that it will keep kind of walking around based on the algorithm which is built in, and in the end it will land somewhere. It will once it finds the minimum that by the algorithm seems the best. So this is the case where this will be, by the previous slide, fmin search will be that function A. And this function, so the curve on which we are looking for the minimum, is the function B. So this function B becomes an input argument for our function A. So let's have a look at how that would be actually done in Matlab. So we can have, again, our function B, so the one which defines this curve, could be defined now in three different ways. It can be a separate file, or it can be part of our script file, and that's when we would have to include end in there, or since it's a one-liner with just one argument, it could as well be just an anonymous function inside our file. So I will write the function. I know that for given x I have y as my output, so I'll just call it y. Then I will call it my curve, so that will be the name of my function. All it needs to calculate is the value of x. And then, of course, we type in that formula. So that's x squared minus 3x plus 2 minus 3 times x plus 2. Okay. And since I'm doing it within my script, I have to remember to end my function. Okay, so that one is ready. And now let's do the fmin search. So just for practice, let's go actually into help and see how it works, even though I have it in the slide, but for your benefit, fmin search, find the minimum of unconstrained multivariable function. So the way to call it is that we give the name. The most basic way is to, as inputs, to give the function of which we look for the minimum and then the starting point, as I said. Alternatively, there can be some additional options, and as such it has one output argument, and that x will define the x coordinate of our minimum point. But we can have also some additional outputs, and then you can read from help what actually they represent. Now I'll use this most basic representation. So again, as I told you, the easiest way or the most secure way to call a function is to copy paste ready syntax, so that you make sure you don't make any error, any typo. So I paste it here, and now I just review what is in here. Basically the names of inputs and outputs. My output, I will call it min x. And then for the inputs, of course, now my function is not called fun, but my curve. And the starting point, I don't have it, I can define it here. x0 is, let's say, 4. Okay, so let's run. Something went wrong, not enough input arguments. Yes, so one thing, when you have your function defined, whether it is kind of the function below your script or if it's a separate file, you have to include handle to that function. So that kind of points to Matlab that, hey, take that and use it. That handle is not needed if my curve is defined as anonymous function, but for a case like this, it actually needs to have a handle. So you see, it says that min x is 1.5. So as I said, that points to the location of the minimum. And now if you really want to believe me that this has actually done the right job, let's plot it. And now I will also use this my curve formula to calculate the points for plotting. So now I want to plot my x for, let's pick something on the left from min x and on the right. So I'll say like this, min x minus 3, let's say, then use some step, and then min x plus 3. So this is my range for x arguments. Now for all those, I need to calculate those values. So I'll call it y, and simply say my curve of x. So I could explicitly write this formula here again, but to avoid, for instance, making a mistake in the formula, I use the one which I know has been used for finding the minimum. So it's very much okay to just use the ready definition. So I have my x and y. Since x is a vector, y is a vector of same size, and that means we can plot it. So we can plot x and y. Let's do that first. So you see, there is our parabola, and now I would like to see that our point that we found to be minimum is actually in the right place. So as I said, this min x defines the x coordinate. So we know that the y means, or min y, so the value of my function in that point would be actually my curve of min x, because once again my curve carries that formula that represents the parabola, and then this is the particular x value for which I want to find the value of y, because that's, if in our figure min x basically tells 1.5, so it only says this x coordinate, but we also need to know the value where, on which height that minimum is. So that's how we find it, by just calculating the value of our function for that given x. So now that I have my, it was in here, so now that I have my min x, min y, I can include them in my plot as a point, min x, min y, and I want to mark those as red circle. Okay, let's run and see. So there we go, you can see that it has actually found it correctly. So, as I said before, alternatively, this curve could have been defined as an anonymous function. So I put it in a comment, my curve equals, then I point that it has one input argument x, and then there comes the formula directly with no more assignment operator or anything like that. So then it would have worked. And the third option was to create a new file, which is then directly function file, and then you save it in the same folder and then you call it from the script file. So either one of those three would have worked perfectly fine, and it demonstrates how this function idea works. So basically it's a function that has another function as an input.